Hello students, in our last video, we saw graphical representation of zeros of quadratic polynomials. So now we know that geometrically a quadratic polynomial can have either two distant zeros or one zero or not even a single zero. This also means that a polynomial of degree 2 has at the most two zeros. Today we will see graphical representation of cubic polynomial. Students, the standard form of cubic polynomial is ax cubed plus bx square plus cx plus d, where a, b, c, d is any real number but a cannot be equal to 0. Now what do you expect the graph of cubic polynomial to be? Let us find out the coordinates of polynomial p of x equal to x cubed minus 4x by converting polynomial to polynomial equation of y equal to px form, which gives us y equal to x cubed minus 4x, and by assigning different values to the variable x, we get different coordinates. We can see here that when we take minus 2 and replace it with x in our polynomial, we get the other value 0. If we take minus 1 as the value of x and put it in equation, we get 3. And by taking various values of x, we get various values of y. Plot the coordinates on the graph. Look at this graph. What do you see? We observe that the graph of y equal to x cubed minus 4x actually looks like this. A double curve. Sort of, yes. There are two curves, but not exactly it is a double curve. This graph looks like it is having S shape and also passes through the origin. Also figure out where else it intercepts the x-axis. Yes, you are right, at two other points, that is minus 2 and 2. Thus minus 2, 0 and 2 are the zeros of polynomial x cubed minus 4x. We can call them alpha, beta and gamma. It may be noted that whenever the value of variable x is greater than 2, the value of y will always be positive, and accordingly the graph will always go up and never turn downwards. Vice versa, if value of variable x is less than minus 2, the value of y will always be negative, and accordingly the graph will always go down and will never turn upwards. We can also verify the zeros by factorizing this polynomial. Let us take few more examples. Consider the cubic polynomial x cubed minus 5x square plus 8x minus 4. Draw the graph of y equal to x cubed minus 5x square plus 8x minus 4 and observe the graph that we get. We will observe that again the curve starts low to the left and goes high to the right. It crosses the x-axis once and then just touches it at x equal to 2. So we have our two roots, x equal to 1 and x equal to 2. Check this by factorizing. It will give x minus 1, x minus 2, x minus 2 equal to 0. In this case, we do have three real roots, but two of them are the same because of the term x minus 2 whole square. So we only have two distinct solutions. Consider the cubic polynomial x cubed minus 3x square plus 3x minus 1. Draw the graph of x cubed minus 3x square plus 3x minus 1 and observe the graph that we get. The curve does cross the x-axis at the point x equal to 1, but the x-axis is also a tangent to the curve at this point. This is indicative of the fact that there are three repeated roots. This polynomial, if we factorize, give x minus 1 whole cube equal to 0. Although there are three factors, they are all the same, and we only have single solution x equal to 1. The corresponding curve is y equal to x cubed minus 3x square plus 3x minus 1 and is shown in figure. Consider cubic polynomial x cubed plus x square plus x minus 3. Plot the graph and see how it looks. Yes, just like all other curves. You can see that the graph crosses the x-axis in one place only. As we saw in previous case, there were three real roots which were coincident at one point, but here there is only one real root. Verify this fact by factorizing. It gives us x minus 1 and x square plus 2x plus 3. The quadratic polynomial x square plus 2x plus 3 equal to 0 has no real solutions. So the only solution to the cubic equation is obtained by putting x minus 1 equal to 0, giving the single solution x equal to 1. From these graphs, you can see why a cubic equation always has at least one real root. The graph either starts large and negative or finishes large and positive. When the coefficient of x cube is positive, or it will start large and positive and finish off large and negative when the coefficient of x cube is negative. The graph of cubic polynomial must cross the x-axis at least once, giving you at least one real root. So any problem you get that involves solving a cubic equation will have a real solution. So we conclude here that zeros of polynomial are the coordinates of x-axis, where the graph of polynomial intercepts the x-axis. A cubic polynomial can have minimum 1 and maximum of 3 zeros. In simple words, maximum zeros of a polynomial will always be limited to its degree. In a linear polynomial, it is always has only one zero, while in quadratic polynomial has 2 or less than 2, and a cubic polynomial has 3 or less zeros.